What if the universe is teeming with life, and we've only just begun to scratch the surface of its mysteries? Imagine standing on the edge of discovery, peering into the vast expanse of space, where countless worlds hold secrets that could change everything we know about existence. Today, we're diving into 25 cosmic wonders that might just be the key to answering one of humanity's most profound questions. Are we alone? From icy moons with hidden oceans to distant planets bathed in the light of alien suns, each of these locations offers a tantalizing glimpse into the possibility of life beyond Earth. Get ready to explore the incredible diversity of these cosmic hotspots, where the conditions for life might be hiding in plain sight. By the end of this journey, you'll not only marvel at the wonders of the universe, but also understand why scientists are so excited about the potential for extraterrestrial life. So, buckle up, this is a voyage you won't want to miss. Now turning to our first cosmic wonder, Europa, one of Jupiter's most intriguing moons. Beneath its icy, cracked surface lies a vast ocean, estimated to be twice the volume of all Earth's oceans combined. This hidden ocean is kept liquid by the gravitational forces exerted by Jupiter, which create enough heat to prevent the water from freezing solid. Scientists believe that hydrothermal vents, similar to those found in Earth's deep oceans, could exist on Europa's ocean floor. These vents, which release heat and minerals, might provide the perfect conditions for microbial life to thrive, just as they do in the darkest depths of our own planet's oceans. Adding to the excitement, NASA Europa Clipper mission is set to launch in the coming years, aiming to conduct detailed reconnaissance of this icy moon. The mission will study Europa's ice shell, subsurface ocean, and potential habitability, bringing us closer than ever to answering the question of whether life could exist beyond Earth. With its combination of liquid water, energy sources, and organic molecules, Europa stands as one of the most promising candidates in our search for extraterrestrial life. As we move forward, this icy moon continues to captivate scientists and dreamers alike, offering a glimpse into the incredible possibilities that lie hidden in the cosmos. Now turning to our second cosmic wonder, Enceladus, one of Saturn's most fascinating moons. This small, icy world has captured the attention of scientists due to its spectacular geysers, which erupt from its south pole, spewing water vapor and icy particles into space. These plumes are not just a stunning visual display, they are strong evidence of a subsurface ocean hidden beneath Enceladus' frozen crust. The presence of liquid water, combined with the discovery of organic molecules like methane and carbon dioxide in these plumes, makes Enceladus a prime candidate in the search for extraterrestrial life. The Cassini mission, which orbited Saturn for over 13 years, played a crucial role in uncovering these secrets. Cassini's flybys of Enceladus allowed it to sample the plumes directly, revealing not only water and organic compounds but also hints of hydrothermal activity on the ocean floor. This activity could provide the energy and nutrients needed to support life, much like the hydrothermal vents found in Earth's deep oceans. The findings from Cassini have sparked excitement and raised new questions about what might be lurking in Enceladus' hidden ocean. Looking ahead, future missions are being planned to explore Enceladus in even greater detail. One proposed mission aims to return to this icy moon, equipped with advanced instruments to analyze its plumes and search for signs of life. With its combination of liquid water, organic molecules, and potential energy sources, Enceladus stands as one of the most promising places in our solar system to find extraterrestrial life. As we continue to explore this tiny moon, it reminds us that even the smallest worlds can hold the biggest secrets, offering a tantalizing glimpse into the possibilities of life beyond Earth. Now turning to our third cosmic wonder, Mars, the red planet that has long captivated our imagination and scientific curiosity. Mars is not just a barren desert world, it holds tantalizing clues that suggest it may have once been a much wetter, more Earth-like planet. Ancient riverbeds, dried-up lake beds, and mineral deposits that only form in the presence of water all point to a time when liquid water flowed freely on its surface. This raises the intriguing possibility that Mars could have once supported life, and perhaps even still does. One of the most exciting areas of exploration is Mars' polar ice caps, which contain vast amounts of water ice. These icy regions, along with evidence of subsurface water reservoirs, suggest that Mars may still have pockets of liquid water hidden beneath its surface. Where there's water, there's potential for life, and this has made Mars a prime target in the search for microbial life, both past and present. The Perseverance rover, currently exploring Mars' Jezero crater, is at the forefront of this search. Jezero crater is believed to have once been a lake, making it an ideal location to hunt for signs of ancient microbial life. Perseverance is equipped with advanced instruments to analyze rocks and soil, and it's even collecting samples that could one day be returned to Earth for further study. These samples could hold the key to answering one of humanity's biggest questions. Are we alone in the universe, but the search for life on Mars doesn't stop at the surface? Scientists are also exploring the possibility of life in Martian caves. These underground caverns, shielded from the planet's harsh radiation and extreme temperatures, could provide a stable environment for microbial life to thrive. Some theories even suggest that these caves might contain liquid water, making them potential oases in an otherwise hostile environment. As we continue to explore Mars, each discovery brings us closer to understanding whether life ever existed or still exists on this enigmatic planet. From its ancient riverbeds to its icy poles and hidden caves, Mars remains one of the most promising places in our solar system to find answers to the mysteries of life beyond Earth. Now turning to our fourth cosmic wonder, Titan, Saturn's largest moon and one of the most intriguing worlds in our solar system. Unlike any other moon, Titan boasts a thick, nitrogen-rich atmosphere, making it the only moon with a substantial atmosphere and the only place besides Earth known to have stable bodies of liquid on its surface. But here's the twist: those lakes and rivers aren't filled with water. Instead, they're made of liquid methane and ethane, creating a landscape that's both alien and eerily familiar. Titan's unique chemistry opens up fascinating possibilities for life, though not as we know it. On Earth, water is essential for life, but on Titan, the extreme cold, hovering around -290 degrees Fahrenheit, means water is frozen solid. However, liquid methane could play a similar role, acting as a solvent for chemical reactions that might give rise to life forms with a completely different biochemistry. Imagine organisms that breathe hydrogen instead of oxygen or use methane the way we use water. It's a world where life, if it exists, would be truly alien. Adding to the intrigue is the upcoming Dragonfly mission, set to launch in the late 2020s. This ambitious NASA mission will send a drone-like rotorcraft to explore Titan's surface, hopping from one location to another to study its chemistry, geology, and potential for habitability. Dragonfly will investigate Titan's organic-rich dunes, its methane lakes, and even its subsurface ocean, which is believed to exist beneath its icy crust. This mission could revolutionize our understanding of life's potential in environments vastly different from Earth's. Titan's thick atmosphere also shields it from harmful radiation, creating a relatively stable environment compared to other moons. This, combined with its complex chemistry, makes Titan a prime candidate for harboring life, or at least the building blocks of life. As we prepare to explore this mysterious moon, one thing is certain: Titan challenges our assumptions about what life requires and where it might exist in the universe. With Dragonfly on the horizon, we may soon uncover secrets that redefine our understanding of life itself. Now turning to our fifth cosmic wonder, Proxima Centauri b, an exoplanet that has captured the imagination of scientists and dreamers alike. Located just over 4 light-years away, this intriguing world orbits Proxima Centauri, the closest star to our solar system. What makes Proxima Centauri B so special is its position within the star's habitable zone, the region where temperatures could allow liquid water to exist on its surface. And where there's water, there's the tantalizing possibility of life. But Proxima Centauri B isn't without its challenges. Its host star, Proxima Centauri, is a red dwarf, a type of star known for its frequent and intense stellar flares. These flares could bombard the planet with harmful radiation, potentially stripping away its atmosphere or making the surface inhospitable. Despite these hurdles, scientists remain hopeful. Proxima Centauri B's proximity to Earth makes it one of the most accessible exoplanets for study, and its potential for liquid water keeps it high on the list of candidates for extraterrestrial life. Adding to the excitement is the Breakthrough Starshot initiative, a bold project aiming to send tiny, light-powered probes to the Proxima Centauri system. These probes, traveling at a fraction of the speed of light, could reach the system in just a few decades, providing us with unprecedented data about Proxima Centauri B and its environment. While the technology is still in its early stages, the initiative represents a giant leap toward interstellar exploration and the search for life beyond our solar system. Proxima Centauri B challenges us to think beyond the familiar. Could life exist on a planet bathed in the dim light of a red dwarf star? Could it survive the harsh radiation of stellar flares? As we continue to study this nearby world, we edge closer to answering these profound questions. With missions like Breakthrough Starshot on the horizon, the dream of exploring another star system and perhaps discovering life there feels closer than ever. Now turning to the TRAPPIST-1 system, a cosmic wonder that has sparked immense curiosity in the search for alien life. This system, located about 40 light-years from Earth, is home to 7 Earth-sized planets orbiting an ultra-cool dwarf star. What makes TRAPPIST-1 truly remarkable is that 3 of these planets, TRAPPIST-1e, F, and G, lie within the star's habitable zone, where conditions might be just right for liquid water to exist on their surfaces. And as we know, liquid water is one of the key ingredients for life as we understand it. The TRAPPIST-1 system offers a unique opportunity for scientists to study multiple potentially habitable worlds in a single star system. The planets are relatively close to one another, which means they could share similar conditions, making it easier to compare their atmospheres and surface features. But the real game changer in studying this system is the James Webb Space Telescope. With its advanced instruments, the telescope can analyze the atmospheres of these planets, searching for signs of water vapor, oxygen, methane, and other gases that could hint at the presence of life. One of the most exciting aspects of TRAPPIST-1 is the possibility of tidal locking. This means that some of these planets might always show the same face to their star, creating stark contrasts between their day and night sides. While this could lead to extreme temperature differences, it also opens up intriguing possibilities for life to thrive in the twilight zones between these two extremes. Could these regions offer a stable environment where life could take hold? It's a question that scientists are eager to explore further. The TRAPPIST-1 system challenges us to rethink what we know about habitability. With its 7 Earth-sized planets and the potential for liquid water on multiple worlds, this system is a treasure trove of possibilities. As the James Webb Space Telescope continues to gather data, we inch closer to uncovering the secrets of these distant worlds. Could one of them be home to life? Only time and the relentless pursuit of science will tell. Now turning to Kepler 452b, a cosmic wonder often referred to as Earth's cousin. This exoplanet stands out as one of the most promising candidates for habitability beyond our solar system. Located approximately 1,400 light-years away in the constellation Cygnus, Kepler 452b orbits a star remarkably similar to our Sun, albeit slightly older and more luminous. What makes this exoplanet so intriguing is its striking resemblance to Earth in several key ways. Kepler 452b is about 60% larger in diameter than Earth, placing it in the category of a super-Earth. Its orbit around its star takes 385 days, just a bit longer than our own year, and it resides comfortably within the habitable zone, where temperatures could allow liquid water to exist on its surface. The presence of liquid water, combined with its Earth-like orbit and a Sun-like star, makes Kepler 452b a tantalizing target in the search for alien life. However, the similarities don't end there. The star Kepler 452b orbits is a G-type star, much like our Sun, which means it provides a stable source of energy over billions of years. This stability is crucial for the development and sustenance of life as we know it. Scientists speculate that if Kepler 452b has a rocky composition and a thick atmosphere, it could potentially support a climate similar to Earth's, with oceans, weather systems, and even continents. Yet, despite these promising characteristics, confirming the presence of life on Kepler 452b remains a significant challenge. Its immense distance from Earth makes direct observation and detailed study extremely difficult. Current telescopes can only provide limited data about its atmosphere and surface conditions. Future missions, equipped with more advanced technology, will be essential to determine whether this Earth-like world truly harbors life. Kepler 452b serves as a reminder of how vast and diverse the universe is, offering worlds that mirror our own in surprising ways. As we continue to explore these distant realms, each discovery brings us closer to answering the profound question, are we alone in the cosmos? Now turning to LHS 1140b, another fascinating cosmic wonder that has captured the attention of astronomers and astrobiologists alike. This super-Earth, located approximately 40 light-years away in the constellation Cetus, orbits a red dwarf star within its habitable zone. What makes LHS 1140b particularly intriguing is its potential to host liquid water, a key ingredient for life as we know it. LHS 1140b is about 1.7 times the size of Earth and nearly 7 times its mass, making it one of the densest exoplanets discovered to date. This density suggests a rocky composition similar to Earth, which raises the possibility of a solid surface and potentially a stable environment for life. The planet's orbit places it in the so-called Goldilocks zone, where temperatures are just right for liquid water to exist, neither too hot nor too cold. One of the most exciting aspects of LHS 1140b is its potential for a thick atmosphere. Red dwarf stars, like the one it orbits, are known for their intense stellar activity, which can strip away the atmospheres of nearby planets. However, LHS 1140b's large size and mass may have allowed it to retain a substantial atmosphere, shielding it from the harsh radiation of its star. This atmosphere could play a crucial role in maintaining stable surface conditions, including the presence of liquid water. The possibility of a thick atmosphere also opens the door to the detection of biosignatures, chemical markers that could indicate the presence of life. Future telescopes such as the James Webb Space Telescope and the Extremely Large Telescope are expected to provide unprecedented insights into the composition of LHS 1140b's atmosphere. By analyzing the light that passes through its atmosphere, scientists hope to identify gases like oxygen, methane, or carbon dioxide, which could hint at biological activity. While LHS 1140b presents a compelling case for habitability, much remains to be discovered. Its distance from Earth and the challenges of studying red dwarf systems mean that confirming the presence of life will require advanced technology and meticulous observation. Nevertheless, LHS 1140b stands as a beacon of hope in the search for extraterrestrial life, reminding us that the universe is filled with worlds that may one day reveal the secrets of life beyond our own. Now turning to GJ 1214b, a truly unique cosmic wonder that has earned the nickname Water World due to its potential for hosting a vast global ocean. Located approximately 40 light-years away in the constellation Ophiuchus, this exoplanet orbits a red dwarf star and has captivated scientists with its intriguing characteristics. GJ 1214b is about 2.7 times the size of Earth and nearly 7 times its mass, placing it in the category of super-Earths. However, what sets it apart is its likely composition: a thick, steamy atmosphere and a surface that may be entirely covered by a deep, planet-wide ocean. The presence of such a massive ocean raises fascinating questions about the possibility of life. On Earth, oceans are teeming with biodiversity, and similar environments on GJ 1214b could, in theory, support life forms adapted to extreme conditions. However, the planet's thick atmosphere, composed primarily of water vapor, hydrogen, and helium, presents a significant challenge for astronomers. This dense haze makes it difficult to study the planet's surface and atmosphere in detail, as it obscures the light passing through and limits our ability to detect potential biosignatures. Despite these challenges, scientists have made progress in understanding GJ 1214b. Observations suggest that the planet's atmosphere is highly reflective, which could indicate the presence of clouds or a thick layer of haze. This reflective quality also means that GJ 1214b absorbs less heat from its star, potentially creating a more stable environment for liquid water to exist. However, the planet's close proximity to its star, completing an orbit in just 38 hours, means it is likely tidally locked, with one side perpetually facing the star and the other in eternal darkness. This could result in extreme temperature differences, with the day side experiencing scorching heat and the night side plunging into freezing cold. The implications for life in such an environment are profound. If GJ 1214b does indeed have a global ocean, life could potentially thrive in the twilight zone between the day and night sides, where temperatures might be more moderate. Alternatively, life could exist in the depths of the ocean, shielded from the harsh conditions on the surface. The challenges of studying GJ 1214b's atmosphere and surface mean that much about this water world remains a mystery. Future missions and advanced telescopes such as the James Webb Space Telescope may provide deeper insights into this enigmatic planet and its potential to harbor life. As we continue to explore the mysteries of GJ 1214b, it serves as a reminder of the incredible diversity of worlds beyond our solar system. Whether or not life exists on this water world, its discovery expands our understanding of the conditions that could support life in the universe, pushing the boundaries of what we once thought possible. Now turning to K2-18b, a remarkable exoplanet that has captured the attention of astronomers and astrobiologists alike. Located approximately 110 light-years away in the constellation Leo, K2-18b orbits within the habitable zone of its red dwarf star, where conditions could allow for liquid water to exist. What makes this planet particularly intriguing is the groundbreaking discovery of water vapor in its atmosphere, a finding that has profound implications for the search for extraterrestrial life. K2-18b is classified as a super-Earth with a radius about 2.6 times that of Earth and a mass nearly 9 times greater. Its position in the habitable zone, combined with the presence of water vapor, suggests that this planet could have a stable climate capable of supporting liquid water on its surface or within its atmosphere. The detection of water vapor was made using data from the Hubble Space Telescope, which analyzed the starlight passing through K2-18b's atmosphere. This discovery marked the first time water vapor was identified in the atmosphere of a habitable zone exoplanet, making it a landmark moment in the field of exoplanet research. The presence of water vapor raises exciting possibilities for life. On Earth, water is essential for all known forms of life, and its presence on K2-18b suggests that similar conditions could exist there. Scientists speculate that the planet might have a thick atmosphere rich in hydrogen, with clouds of water vapor and possibly even rain. Beneath this atmosphere, K2-18b could host a vast ocean, potentially creating an environment where life could thrive. However, the planet's high gravity and intense radiation from its red dwarf star present challenges for habitability, as they could make surface conditions harsh and unpredictable. To better understand K2-18b and its potential for life, astronomers are eagerly awaiting observations from the James Webb Space Telescope. This advanced telescope will be able to analyze the planet's atmosphere in greater detail, searching for additional molecules such as methane, oxygen, or carbon dioxide chemicals that could indicate the presence of life. The James Webb Space Telescope's ability to study the composition and structure of exoplanet atmospheres will provide critical insights into whether K2-18b could indeed be a haven for life. As we continue to explore K2-18b, it stands as a testament to the incredible progress being made in the search for habitable worlds beyond our solar system. The discovery of water vapor in its atmosphere not only fuels our curiosity, but also brings us one step closer to answering the age-old question: are we alone in the universe? With each new finding, we gain a deeper understanding of the cosmic wonders that could harbor life, reminding us of the vast possibilities that lie among the stars. Now turning to Gliese 667cc, a fascinating super-Earth that offers a unique glimpse into the complexities of habitable worlds in multi-star systems. Located approximately 23.6 light-years away in the constellation Scorpius, Gliese 667cc orbits within the habitable zone of its star, Gliese 667c, which is part of a triple-star system. This intriguing setup makes Gliese 667cc one of the most studied exoplanets in the search for extraterrestrial life. Gliese 667cc is roughly 4.5 times the mass of Earth, placing it firmly in the category of super-Earths. Its position in the habitable zone suggests that it could have the right conditions for liquid water to exist on its surface, a key ingredient for life as we know it. However, the presence of two additional stars in the system adds a layer of complexity. While these stars are farther away and less influential than Gliese 667c, they could still affect the planet's climate and stability, creating a dynamic and potentially challenging environment. One of the most significant challenges for Gliese 667cc is the possibility of tidal locking. This occurs when a planet's rotation matches its orbit around its star, causing one side to permanently face the star while the other remains in perpetual darkness. If Gliese 667cc is tidally locked, it could result in extreme temperature differences between its day and night sides. The day side might be scorchingly hot, while the night side could be freezing cold. However, some scientists speculate that a thick atmosphere could help distribute heat, potentially creating a narrow band of habitable conditions along the planet's twilight zone. Despite these challenges, Gliese 667cc remains a compelling candidate for habitability. Its proximity to Earth, relatively speaking, makes it an ideal target for further study. Future telescopes such as the James Webb Space Telescope could provide more detailed observations of its atmosphere, searching for signs of water vapor, oxygen, or other biomarkers. These findings could shed light on whether Gliese 667cc's complex stellar environment is a barrier to life or a unique opportunity for it to thrive. As we explore Gliese 667cc, we are reminded of the incredible diversity of exoplanets and the many factors that influence their potential to support life. This super-Earth, with its triple star system and potential for tidal locking, challenges our understanding of habitability and pushes us to consider new possibilities in the search for life beyond our solar system. With each discovery, we come closer to unraveling the mysteries of the cosmos and answering the profound question, could life exist in such a complex and dynamic environment? Now turning to HD 40307G, another intriguing super-Earth that captures the imagination of astronomers and space enthusiasts alike. Located approximately 42 light-years away in the constellation Pictor, HD 40307G orbits within the habitable zone of its star, HD 40307. This places it in the sweet spot where temperatures could allow liquid water to exist on its surface, a critical factor in the search for life beyond Earth. HD 40307G is estimated to be at least 7 times the mass of Earth, making it a true super-Earth. Its size suggests it could have a thick atmosphere, which might help regulate surface temperatures and create conditions suitable for life. A dense atmosphere could also protect the planet from harmful radiation, further enhancing its potential habitability. However, the exact composition of this atmosphere remains a mystery, as studying distant exoplanets like HD 40307G poses significant challenges. One of the primary obstacles in understanding HD 40307G is its distance from Earth. At 42 light-years away, it's far beyond the reach of current space probes, meaning we must rely on telescopes to gather data. Observations so far have revealed that HD 40307G has a relatively long orbital period, taking about 200 days to complete one trip around its star. This extended orbit could result in seasonal variations, adding another layer of complexity to its climate and potential habitability. Despite these challenges, HD 40307G remains a promising target for future missions. Advanced telescopes such as the James Webb Space Telescope could provide more detailed insights into its atmosphere, searching for signs of water vapor, carbon dioxide, or even methane gases that could hint at biological activity. Additionally, future missions designed to study exoplanet atmospheres could help us better understand whether HD 40307G's thick atmosphere is capable of supporting life. As we explore HD 40307G, we are reminded of the vastness of the universe and the incredible diversity of worlds it contains. This super-Earth, with its potential for a thick atmosphere and liquid water, represents yet another piece of the puzzle in our quest to find life beyond our solar system. Each discovery brings us closer to understanding the conditions that make a planet habitable and the possibilities that lie hidden among the stars. With every new observation, we inch closer to answering the age-old question, are we alone in the cosmos? Now turning to Wolf 1061c, an exoplanet that offers a fascinating glimpse into the possibilities of life beyond our solar system. Located just 14 light-years away in the constellation Ophiuchus, Wolf 1061c orbits within the habitable zone of its red dwarf star, Wolf 1061. This proximity to its star makes it one of the closest potentially habitable exoplanets to Earth, sparking excitement among astronomers and space enthusiasts alike. Wolf 1061c is a super-Earth, estimated to be about 4 times the mass of our planet. Its location in the habitable zone suggests that it could have the right conditions for liquid water to exist on its surface, a key ingredient for life as we know it. However, its close orbit to its star, completing a full revolution in just 18 days, presents unique challenges. The planet's proximity to Wolf 1061 means it is likely tidally locked, with one side perpetually facing the star and the other side in constant darkness. This could create extreme temperature differences between the two hemispheres, potentially making habitability a complex issue. Another factor to consider is the nature of red dwarf stars themselves. While they are smaller and cooler than stars like our Sun, They are also known for their intense stellar activity, including frequent flares and radiation bursts. These events could bombard Wolf 1061c with harmful radiation, posing a threat to any potential life forms. Additionally, the planet's atmosphere, if it exists, would need to be robust enough to shield its surface from these extreme conditions. Despite these challenges, Wolf 1061c remains a compelling target for further study. Its relative closeness to Earth makes it an ideal candidate for observations using advanced telescopes like the James Webb Space Telescope. By analyzing its atmosphere, scientists hope to detect signs of water vapor, oxygen, or other gases that could indicate the presence of life. Future missions aimed at studying exoplanet atmospheres could also shed light on whether Wolf 1061c's environment is capable of supporting life despite its harsh conditions. As we explore Wolf 1061c, we are reminded of the delicate balance required for a planet to be habitable. Its extreme weather, tidal locking, and exposure to stellar radiation highlight the challenges of finding life in the cosmos. Yet, it also underscores the incredible diversity of worlds that exist beyond our solar system. Each discovery, like Wolf 1061c, brings us one step closer to understanding the conditions that make life possible and the potential for finding it in the most unexpected places. With every new observation, we continue to unravel the mysteries of the universe and our place within it. Now turning to Kepler-62f, an Earth-sized exoplanet that has captured the attention of astronomers for its potential to host life. Located approximately 1,200 light-years away in the constellation Lyra, Kepler-62f orbits within the habitable zone of its star, Kepler-62. This means it receives just the right amount of stellar energy to allow liquid water to exist on its surface, a critical factor in the search for extraterrestrial life. Kepler-62f is about 1.4 times the size of Earth, making it one of the most Earth-like exoplanets discovered to date. Its size and location in the habitable zone have led scientists to speculate about the possibility of oceans, continents, and even a stable climate. However, much about this distant world remains a mystery. Unlike some exoplanets, Kepler-62f's atmosphere has not yet been directly observed, leaving questions about its composition and whether it could support life. One of the key challenges in studying Kepler-62f is its distance from Earth. At over 1,000 light-years away, it is far beyond the reach of current space missions. This makes it difficult to gather detailed data about its atmosphere, surface conditions, or potential biosignatures. However, future telescopes such as the James Webb Space Telescope and other advanced observatories could provide the tools needed to analyze its atmosphere for signs of water vapor, oxygen, or other gases that might indicate habitability. Another intriguing aspect of Kepler-62f is its star, Kepler-62, which is smaller and cooler than our Sun. This means the planet's habitable zone is much closer to its star, and Kepler-62f likely experiences a different climate compared to Earth. Scientists have theorized that the planet could have a thick atmosphere to trap heat, potentially creating a greenhouse effect that keeps its surface warm enough for liquid water. Alternatively, if its atmosphere is thin or non-existent, the planet could be a frozen world with any water locked in ice. Despite these uncertainties, Kepler-62f remains a prime candidate in the search for life beyond our solar system. Its Earth-like size and location in the habitable zone make it a tantalizing target for future exploration. As technology advances, astronomers hope to uncover more about this distant world, bringing us closer to answering the age-old question, are we alone in the universe? With each new discovery, we gain a deeper understanding of the incredible diversity of planets that exist and the potential for life to thrive in the most unexpected corners of the cosmos. Now turning to Kepler-186f, a groundbreaking discovery in the search for extraterrestrial life. This exoplanet holds the distinction of being the first Earth-sized world found orbiting within the habitable zone of its star, Kepler-186. Located approximately 500 light-years away in the constellation Cygnus, Kepler-186f represents a significant milestone in our understanding of potentially habitable planets beyond our solar system. Kepler-186f is only about 10% larger than Earth, making it one of the closest matches to our own planet in terms of size. Its location in the habitable zone means it receives just enough energy from its star to allow liquid water to exist on its surface, a key ingredient for life as we know it. However, Kepler-186f star is a red dwarf, much smaller and cooler than our Sun. This means the planet's habitable zone is much closer to its star, and Kepler-186f likely experiences a very different environment compared to Earth. One of the challenges posed by Kepler-186f's dim star is the potential for tidal locking. This phenomenon occurs when a planet's rotation synchronizes with its orbit, causing one side to permanently face the star while the other remains in perpetual darkness. If Kepler-186f is tidally locked, it could have extreme temperature differences between its day and night sides, creating a harsh environment for life. However, some scientists speculate that a thick atmosphere could help distribute heat more evenly, potentially making parts of the planet habitable. Another factor to consider is the star's activity. Red dwarf stars are known for their frequent and intense stellar flares, which could bombard Kepler-186f with harmful radiation. This raises questions about whether the planet could maintain a stable atmosphere or support life over long periods. Despite these challenges, the discovery of Kepler-186f remains a landmark achievement. It demonstrated that Earth-sized planets could exist in the habitable zones of other stars, expanding the possibilities for finding life beyond our solar system. The significance of Kepler-186f lies not only in its potential for habitability, but also in what it represents for the future of space exploration. Its discovery has inspired astronomers to search for similar worlds, using advanced telescopes like the James Webb Space Telescope to study their atmospheres for signs of water vapor, oxygen, or other biosignatures. As we continue to explore the cosmos, Kepler-186f serves as a reminder of the incredible diversity of planets that exist and the tantalizing possibility that life may be waiting to be discovered in the most unexpected places. Now turning to Ross 128b, an exoplanet that offers a unique glimpse into the potential for life beyond our solar system. Located just 11 light-years away in the constellation Virgo, Ross 128b orbits a quiet red dwarf star, making it one of the closest potentially habitable exoplanets to Earth. What sets Ross 128b apart is its relatively calm stellar environment. Unlike many red dwarf stars which are prone to violent flares, Ross 128b's host star is remarkably stable, reducing the risk of harmful radiation and increasing the chances of maintaining a hospitable atmosphere. Ross 128b lies within its star's habitable zone, where temperatures could allow liquid water to exist on its surface. While the planet is about 1.3 times the mass of Earth, its exact size and composition remain uncertain. Scientists believe it could be a rocky world similar to our own, with the potential for a thick atmosphere that could help regulate temperatures and protect against stellar radiation. The stability of its star also means that Ross 128b is less likely to experience the extreme tidal locking seen in other red dwarf systems, potentially allowing for more even heat distribution across its surface. However, studying Ross 128b's atmosphere presents significant challenges. Its proximity to its star means that the planet is likely tidally locked, with one side perpetually facing the star and the other in constant darkness. This could create extreme temperature differences, making it difficult for life to thrive. Additionally, the faintness of red dwarf stars makes it challenging to observe the planet directly or analyze its atmosphere for signs of water vapor, oxygen, or other biosignatures. Despite these challenges, ROSS 128b remains a prime target for future missions. Advanced telescopes like the James Webb Space Telescope and ground-based observatories equipped with next-generation instruments could provide critical insights into its atmosphere and surface conditions. The discovery of ROSS 128b has also fueled excitement about the possibility of finding life in our cosmic neighborhood, reminding us that the search for extraterrestrial life is not confined to distant stars but may be closer than we ever imagined. As we continue to explore the cosmos, ROSS 128b stands as a beacon of hope, offering a tantalizing glimpse into the potential for life just beyond our reach. Now turning to Teegarden star B and C, two intriguing exoplanets that bring us closer to answering the question of whether life exists beyond Earth. Located just 12 light-years away, these Earth-sized worlds orbit a small, dim red dwarf star known as Teegarden star. Both planets lie within their star's habitable zone, where conditions might allow liquid water to exist, a key ingredient for life as we know it. What makes Teegarden star B and C particularly fascinating is their size and proximity to their star, raising hopes that they could host environments capable of supporting life. Teegarden star B, the inner planet, completes an orbit around its star in just 4.9 Earth days, while Teegarden star C, the outer planet, takes 11.4 days. Despite their close orbits, both planets are considered potentially habitable due to the star's low energy output. However, their proximity to the star also means they are likely tidally locked, with one side always facing the star and the other in perpetual darkness. This could create extreme temperature differences, posing challenges for the development of life. On the brighter side, the presence of liquid water remains a possibility, especially in regions where temperatures might be more moderate, such as along the terminator line, the boundary between the day and night sides. One of the biggest challenges in studying Teegarden star B and C is their faint host star. Red dwarfs like Teegarden star emit very little light, making it difficult to observe these planets directly or analyze their atmospheres for signs of water vapor, oxygen, or other biosignatures. However, advancements in telescope technology, such as the James Webb Space Telescope and future ground-based observatories, could provide the tools needed to peer into these distant worlds. Detecting atmospheric gases like carbon dioxide or methane could offer clues about their potential habitability and whether life might exist there. The discovery of Teegarden star B and C has sparked excitement among astronomers as they represent some of the closest Earth-sized exoplanets in the habitable zone of their star. Their study not only expands our understanding of planetary systems around red dwarfs, but also brings us one step closer to finding life in our cosmic neighborhood. As we continue to explore these distant worlds, Teegarden star B and C remind us that the search for extraterrestrial life is a journey filled with both challenges and incredible possibilities. Now turning to HD 85512b, a super-Earth that has captured the attention of astronomers for its potential to host life. Located approximately 36 light-years away, this exoplanet orbits within the habitable zone of its star, HD 85512, a K-type star slightly cooler and dimmer than our Sun. What makes HD 85512 be particularly intriguing is its size, about 3.6 times the mass of Earth, and its position in the so-called Goldilocks zone, where temperatures could allow liquid water to exist on its surface. The possibility of liquid water is a tantalizing clue that HD 85512b might be habitable. However, the planet's thick atmosphere presents both opportunities and challenges. On one hand, a dense atmosphere could help regulate temperatures and protect the surface from harmful radiation, creating a stable environment for life. On the other hand, the composition of this atmosphere remains a mystery. If it's dominated by greenhouse gases like carbon dioxide or methane, the planet could experience a runaway greenhouse effect, making it too hot for liquid water to persist. Alternatively, if the atmosphere contains oxygen or other biosignatures, it could hint at the presence of life. Studying HD 85512b's atmosphere is no easy task. Its host star, while relatively close in astronomical terms, is still faint compared to brighter stars, making detailed observations challenging. Current telescopes struggle to gather enough light to analyze the planet's atmospheric composition. However, future observatories like the James Webb Space Telescope and the extremely large telescope under construction in Chile could change the game. These advanced instruments will have the sensitivity to detect key gases in HD 85512b's atmosphere, providing critical insights into its habitability. The discovery of HD 85512b has added another exciting candidate to the growing list of potentially habitable worlds. Its study not only deepens our understanding of super-Earths, but also highlights the importance of technological advancements in the search for extraterrestrial life. As we continue to explore distant exoplanets, HD 85512b serves as a reminder that the universe is full of surprises, and each discovery brings us closer to answering the ultimate question: are we alone? Now turning to Kepler-22b, a fascinating exoplanet that has sparked excitement in the search for Earth-like worlds. Located about 600 light-years away, Kepler-22b orbits within the habitable zone of its star, a region where conditions might be just right for liquid water to exist. This discovery, made by NASA Kepler spacecraft, marked a significant milestone in the hunt for potentially habitable planets beyond our solar system. Kepler-22b is roughly 2.4 times the size of Earth, making it a super-Earth. Its larger size raises intriguing questions about its composition and environment. While its exact nature remains uncertain, scientists speculate that it could be a rocky planet with a thick atmosphere, or perhaps even a water world with a global ocean. The presence of liquid water is a key factor in assessing its habitability, and Kepler-22b's position in the habitable zone makes it a strong candidate for further study. However, its size also presents challenges. A planet of this magnitude could have a much stronger gravitational pull than Earth, potentially affecting its atmosphere and surface conditions. Additionally, the type of star it orbits, a G-type star similar to our Sun, means that Kepler-22b receives a comparable amount of sunlight, but its larger size could lead to a thicker atmosphere, possibly trapping heat and creating a greenhouse effect. These factors make it difficult to determine whether the planet is truly Earth-like or if its environment is more extreme. The discovery of Kepler-22b was a groundbreaking moment in astronomy. It was one of the first exoplanets confirmed to lie within the habitable zone of a Sun-like star, reigniting hope that Earth-like planets might be more common than previously thought. While much about Kepler-22b remains unknown, its discovery underscores the importance of missions like Kepler in expanding our understanding of the cosmos. As we continue to explore distant worlds, Kepler-22b stands as a reminder of the incredible diversity of planets that exist beyond our solar system and the tantalizing possibility that some of them might harbor life. Now turning to GJ357d, a super-Earth that has captured the attention of astronomers as another promising candidate in the search for habitable worlds. Located just 31 light-years away, GJ357d orbits within the habitable zone of its star, a red dwarf known as GJ357. This relatively close proximity makes it one of the more accessible exoplanets for study, offering a unique opportunity to explore its potential for supporting life. GJ357d is about 6 times the mass of Earth, placing it firmly in the category of super-Earths. Its position in the habitable zone suggests that it could have the right conditions for liquid water to exist on its surface, a key ingredient for life as we know it. However, the planet's habitability depends heavily on its atmosphere. If GJ357d has a thick atmosphere, it could trap enough heat to maintain liquid water, even though it receives less energy from its star compared to Earth. On the other hand, a thin or non-existent atmosphere could leave the planet cold and barren. One of the biggest challenges in studying GJ357d is its distance from its star. Red dwarfs are much cooler and dimmer than stars like our Sun, which means GJ357d orbits much closer to its star to remain in the habitable zone. This close orbit could result in tidal locking, where one side of the planet permanently faces the star, creating extreme temperature differences between the day and night sides. Such conditions could make habitability difficult, but not impossible, especially if the planet has a robust atmosphere to distribute heat. Future missions will play a crucial role in unlocking the mysteries of GJ357d. Advanced telescopes like the James Webb Space Telescope could analyze its atmosphere for signs of water vapor, carbon dioxide, or other gases that might indicate the presence of life. These observations will help scientists determine whether GJ357d is a true Earth-like world or a more extreme environment. As we continue to explore the cosmos, GJ357d stands as a reminder of the incredible diversity of planets and the tantalizing possibility that life might exist in the most unexpected places. Now turning to TOI 700d, an Earth-sized exoplanet that has sparked excitement among astronomers for its potential to host life. Located just over 100 light-years away, TOI 700d orbits within the habitable zone of its star, TOI 700, a small, cool red dwarf. This discovery, made by NASA, a Transiting Exoplanet Survey Satellite, or TESS, marked a significant milestone in the search for habitable worlds beyond our solar system. TOI 700d is particularly intriguing because it is one of the few Earth-sized planets found in the habitable zone of its star. Its size and location suggest that it could have the right conditions for liquid water to exist on its surface, a critical factor for life as we know it. However, the planet's habitability is influenced by the nature of its star. TOI 700 is a dim, cool star, which means the planet receives less energy compared to what Earth gets from the Sun. This raises questions about whether TOI 700d could maintain a stable climate capable of supporting life. One of the challenges in studying TOI 700d is its dim star. Red dwarfs like TOI 700 are known for their variability, often emitting powerful flares that could strip away a planet's atmosphere or make surface conditions hostile. However, TOI 700 appears to be unusually quiet for a red dwarf, which increases the chances that TOI 700d could retain its atmosphere and potentially support life. Still, the planet's proximity to its star means it could be tidally locked, with one side perpetually facing the star and the other in eternal darkness. This could create extreme temperature differences, though a thick atmosphere might help distribute heat more evenly. The TESS mission played a pivotal role in discovering TOI 700d, and future observations will be crucial in unraveling its mysteries. Upcoming telescopes like the James Webb Space Telescope could analyze the planet's atmosphere for signs of water vapor, oxygen, or other gases that might indicate the presence of life. These studies will help scientists determine whether TOI 700d is a true Earth-like world or a more extreme environment. As we continue to explore the cosmos, TOI 700d stands as a testament to the incredible diversity of planets and the enduring hope that life might exist elsewhere in the universe. Now turning to LP 79118d, a fascinating super-Earth that has captured the attention of astronomers for its unique characteristics. Located in the habitable zone of its star, this planet offers a tantalizing possibility for liquid water, a key ingredient for life as we know it. LP 791-18d is slightly larger than Earth, and its position within the habitable zone suggests that it could have the right conditions to support water in its liquid form. However, what makes this planet truly intriguing is its volcanic activity, which adds both challenges and opportunities for habitability. Volcanic activity on LP 791-18d could play a significant role in shaping its environment. On one hand, frequent eruptions might release gases that contribute to the planet's atmosphere, potentially creating a stable climate. On the other hand, intense volcanic activity could also make the surface unstable, with lava flows and ash clouds posing challenges for any potential life forms. The planet's volcanic nature raises questions about whether it could maintain a balance between geological activity and habitability, making it a compelling target for further study. One of the most exciting aspects of LP 791-18d is the potential to study its atmosphere. Future telescopes like the James Webb Space Telescope could analyze the gases present in its atmosphere, searching for signs of water vapor, carbon dioxide, or even methane. These gases could provide clues about the planet's geological processes and whether it has the right conditions to support life. Additionally, understanding the composition of its atmosphere could help scientists determine how volcanic activity influences its habitability. As we continue to explore the cosmos, LP 791-18d stands out as a unique world that challenges our understanding of what makes a planet habitable. Its combination of volcanic activity and potential for liquid water makes it a prime candidate for future missions and observations. By studying this super-Earth, we may uncover new insights into the diversity of planetary environments and the possibility of life beyond our solar system. Now turning to WASP-121b, a truly extraordinary exoplanet that defies our expectations of what a planet can be. Known as a hot Jupiter, this gas giant orbits incredibly close to its star, resulting in scorching temperatures that make it one of the most extreme environments in the known universe. What sets WASP-121b apart is its glowing atmosphere, which has been observed to emit light due to the intense heat. This phenomenon makes it a fascinating subject for astronomers, as it offers a rare glimpse into the behavior of planets under such extreme conditions. The temperatures on WASP-121b are nothing short of staggering, reaching highs that can vaporize metals. The day side of the planet, which always faces its star, is so hot that it causes molecules in the atmosphere to break apart, creating a glowing, otherworldly aura. This extreme heat also means that the planet is unlikely to support life as we know it, but it raises intriguing questions about the possibility of exotic forms of life that could thrive in such harsh environments. Could there be organisms adapted to survive in these blistering temperatures, or perhaps even utilize the intense energy for their survival? While this remains speculative, the idea pushes the boundaries of our understanding of life's potential diversity. The Hubble Space Telescope has played a crucial role in studying WASP-121b, providing detailed observations of its atmosphere. By analyzing the light emitted and absorbed by the planet, scientists have been able to detect the presence of water vapor and other molecules despite the extreme conditions. These findings not only deepen our understanding of hot Jupiters, but also highlight the resilience of certain chemical compounds in the face of overwhelming heat. Future observations with advanced telescopes may reveal even more about this glowing world, shedding light on the complex interactions between a planet's atmosphere and its star. As we explore WASP-121b, we are reminded of the incredible diversity of planets in the universe. This hot Jupiter challenges our assumptions about habitability and opens up new avenues for research into the extremes of planetary environments. By studying worlds like WASP-121b, we expand our understanding of what is possible in the cosmos and continue our search for life in its many potential forms. Now turning to 55 Cancri e, a super-Earth that presents one of the most extreme and fascinating environments in the cosmos. This planet, often referred to as a lava world, has a surface that is perpetually covered in molten lava, with temperatures soaring high enough to melt rock. Its close orbit to its star means that one side of the planet is always facing the intense heat, creating a scorching, inhospitable landscape that challenges our understanding of planetary conditions. The surface of 55 Cancri e is a fiery inferno, with rivers of lava flowing across its terrain and an atmosphere that may be composed of vaporized rock. The extreme heat and pressure make it nearly impossible for life as we know it to exist on the surface. However, scientists have begun to speculate about the possibility of life existing beneath the surface where conditions might be more stable. Could there be subsurface environments shielded from the intense heat where microbial life could potentially thrive? While this remains a tantalizing hypothesis, it underscores the resilience and adaptability of life in even the most hostile environments. Studying 55 Cancri e's atmosphere is crucial for understanding its potential habitability. Observations have revealed that the planet may have a thick atmosphere composed of carbon-based compounds, which could play a role in regulating its extreme temperatures. By analyzing the composition and behavior of this atmosphere, scientists hope to uncover clues about the planet's internal structure and the possibility of subsurface environments that could support life. Future missions and advanced telescopes will be key to unlocking these mysteries, offering a deeper look into this molten world. As we explore 55 Cancri e, we are reminded of the incredible diversity of planetary environments in the universe. This lava world pushes the boundaries of what we consider habitable and challenges us to think creatively about where life might exist. By studying such extreme worlds, we expand our understanding of the cosmos and continue our search for life in its many possible forms. Now turning to the PSR B1257+12 system, a truly unique and mysterious corner of the cosmos. This system is home to some of the most unusual planets ever discovered, orbiting a pulsar, a highly magnetized, rapidly spinning neutron star. Pulsars are the remnants of massive stars that have exploded in supernova, leaving behind dense cores that emit intense beams of radiation. The planets in this system, known as pulsar planets, exist in an environment unlike any other, where the conditions are extreme and the rules of habitability are rewritten. The pulsar at the center of this system bombards its planets with high levels of radiation, creating a harsh and hostile environment. The intense radiation and gravitational forces make it nearly impossible for life as we know it to survive on the surface of these planets. However, scientists have speculated about the possibility of extremophiles organisms that thrive in extreme conditions, existing in shielded environments beneath the surface. Could life find a way to adapt to such a high radiation environment, perhaps in subsurface oceans or deep within rocky layers? While this remains a speculative idea, it challenges our understanding of where life might exist in the universe. The discovery of the PSR B1257+12 system was groundbreaking because it was the first time planets were found orbiting a pulsar. This discovery expanded our understanding of habitable zones, showing that life-sustaining environments might exist in places we never imagined. It also raised questions about how these planets formed in the aftermath of a supernova, a process that would typically destroy any existing planetary systems. The existence of these pulsar planets suggests that planetary formation is more resilient and versatile than we once thought. Studying this system provides valuable insights into the diversity of planetary environments and the potential for life in extreme conditions. Future missions and advanced telescopes will be essential in exploring these pulsar planets further, helping us uncover the secrets of their formation and the possibility of life in such a unique setting. As we continue to explore the cosmos, discoveries like the PSR B1257+12 System remind us that the universe is full of surprises, and the search for life must remain as open-minded as the cosmos itself. Now turning to the conclusion of our journey through the cosmos, we've explored 25 incredible cosmic wonders, each with its own unique potential to harbor alien life. From the icy oceans of Europa and Enceladus to the methane lakes of Titan, and from the distant exoplanets like Proxima Centauri b and Kepler 452b to the extreme environments of pulsar planets in the PSR B1257+12 System, the universe has shown us just how diverse and mysterious it truly is. These locations challenge our understanding of habitability and remind us that life, in some form, could exist in places we once thought impossible. The search for extraterrestrial life is far from over. Each discovery, whether it's water vapor in the atmosphere of K218b or organic molecules in the plumes of Enceladus, brings us one step closer to answering the profound question, are we alone in the universe? Future missions like NASA Europa Clipper and the James Webb Space Telescope will play a crucial role in uncovering these cosmic secrets. They will help us peer deeper into the atmospheres of distant worlds, explore subsurface oceans, and perhaps even detect signs of life beyond Earth. As we reflect on these 25 cosmic wonders, it's clear that the universe is vast, full of surprises, and teeming with possibilities. The search for life is not just about finding answers, it's about expanding our horizons, challenging our assumptions, and embracing the unknown. So stay curious, keep exploring, and follow the latest discoveries in space exploration. Who knows what incredible revelations await us in the stars? Don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss an update on the wonders of the cosmos. The universe is waiting, let's discover it together.